All right, so let's read the first problem together. We've got, in 1990, the population of South Carolina was approximately 3,486,000. During the next 5 years, the population increased by approximately 37,400 people per year. Write a linear equation to model the population P of South Carolina in terms of T, the number of years since 1990. You guys have been doing this for quite some time. So you kind of already know how to begin, I'm hoping. So I know what the population was in 1990, right? And then aren't I going to add to that 37,400 people more each year? Right? Aren't I starting here and then I'm just going to add this many people every year? Don't let the fact that they're big numbers throw you off, right? This is what I started with. And then every year, I'm going to add this many more people. Lily, go ahead.
3,486,000 plus 37,400 T equals P.
That's it. I'm going to put the equals P on this side if you don't mind. So, P, the population, is equal to everybody that I already had, plus another 37,000 each year. So that's why I throw a T on there. That's it. That's all there is to this one. Notice, if I just write it, I'm just going to swap those two. If I write it like this, and I put this first, 37,400 T, and then plus the 3 million, this is like I have an equation in slope-intercept form. Here's my y-intercept, and that's my slope. Every year, I'm adding an additional 37,400. And this is where I started. So, what do you think I do in part B? Estimate the population of South Carolina in 1996. Emma?
You would put 6 in for T.
Why wouldn't I put in 1,996?
Because you're increasing 6 years. That's just the D.
Exactly. So, remember, look at what T stands for back in our, right here. It says T is the number of years since 1990. So 1996 is only 6 years since 1990. So you just pop in a 6 for T. And let me grab my calculator. Got it. Whoops. So I'm just going to pop in a 6 for the number of years. And I'll be able to estimate their population in 1996. And we get a population of 3,710,400 people. How's that? Not so bad? So let's try this second one. I like this one a little bit better because it's easier to wrap your mind around here. So we have a rental company that charges a flat fee of $30 and then an additional 25 cents per mile to rent a moving van. So see if you can do part A. Write an equation that shows what your total cost is going to be. So you're going to rent the thing for 30 bucks and then every mile you drive you pay an additional 25 cents. Matt, you have an answer?
No, I just have a question.
Oh,
Does it
good.
matter what letters you use?
No. So, I personally always use X and Y. Always. So in the last problem, I would have called PY and I would have called TX.
But will you count us down?
No. The reason why I like to use X and Y all the time is because if I want to now graph this, right, I don't know which axis is P and T and it gets all confusing. So I always use the X's and Y's. Do you have to? No. Yeah.
And
Oh, go ahead. What is your linear equation?
I said y equals 0.25x plus 30.
Perfect. Does everybody know why the x is on the 0.25 and not on the 30? Yeah, it's 25 cents per mile. I don't know how many miles I'm driving yet, so 0.25 times however many miles I end up driving. The $30 is a one-time fee. So it's just 30 bucks, and then I'll also pay the 25 cents per mile. Are you wrong if you said y equals 30 plus 0.25x? No. But I personally like to write it in this form because if I did want to graph it, it's already in y equals mx plus b form. I'm already good to go. I know my y-intercept is at 30, then my slope would be a 0.25. Okay? So then in part B, it should be easy enough. How am I going to answer this? What's the cost if you rent a van and drive 130 miles? What do I do to figure this out?
Multiply 130 by 0.25.
Yeah, I'm just going to pop in a 130 for x, and I should be able to ask Mr. Calculator what that value will be.
So it's going to be like 62.
62.5 is correct. Since it's money, you're going to write it as 62.50. Yep. Sure. Okay, so let's look at this third one is interesting because this one's a little bit different. So, you receive a raise of $1,500 a year as a veterinary technician. At the end of your third year, you are making $32,000. So, this is at the end of the third year, I'm making $32,000. Write a linear equation to model your total salary S in terms of the number of years N since you started. I'll give you a hint. Your equation is not going to be 1,500x plus 32,000 because you didn't make 32,000 when you started. So I would actually answer part B first. Lily, you got an answer for part B?
Oh, I thought you wanted A.
Oh. I want A after B. Did anybody figure out B? What was your salary when you started? Liliana? 27,500. Where in the world did you get that number?
Well, it says the third year,
Mm-hmm.
yeah, I mean 32,000, so I just multiplied 3 times 1,500.
Exactly. You've been getting a $1,500 raise every year for 3 years. Okay, so we're taking a snapshot of where you are 3 years in. But if you want to figure out where you started and you can't remember, well, you got this $1,500 raise 3 times. So 1,500 times 3, take that away from 32,000, that must have been your starting point. Does that make sense? Is that a yes? Okay, now I can go back and answer A. So, Lily, what did you say for A?
He said, n plus, 4,500 equals 32,000.
What are you doing with 4,500?
That's 1,500 times.
Oh. That's not gonna model your total salary though. So your total salary, every year you're getting $1,500, right? But you started at 27,500. So if I'm gonna use X's and Y's if you don't mind. I'm getting $1,500 more every year. Right? So there's my raise of $1,500 per year. But I started at 27,500. So that should model me. Think about it. At year 0, my first year, right? So I haven't finished a full year yet. I would put in 0 for X and I made 2750 or 27,500. After 1 year, I put in a 1. I get 1,500 plus the 27,500. That gets me up to 29,000. At the end of 2 years, I plug in a 2. That's 3,000. Add that on. That's 30,500. And at the end of my 3rd year, which is where I'm at, if I plug in a 3, I get 4,500 here. Add that to this, and it gets me to the 32,000 that I'm making currently. Does that make sense? So this one was a little weird. You just really kind of had to backtrack first to figure out, okay, I started here, and this equation will model me no matter how many years I decide to stay as a veterinary technician. So now I can easily answer part C. What will your salary be at the end of your 7th year? So all I have to do with my nice equation is what?
7.
Yeah, pop in a 7 for X. And if all goes to plan, if you keep getting this $1,500 raise, you'll end up making how much? Who's got it? Did everybody plug in a 7? That's it. 38,000.